All right. Hi, everybody. Thanks for joining us for our next Lunch and Learn session. This is on Ubiquitous Intelligence with Brandon Gomez, and he's going to lead us through the topic. So I will hand it over.
Everyone, I'm Brandon. Thank you for coming to or watching at your own leisure today's session. I'll try to make the most of your time. We're going to be talking about a lot today and walking the line between technical use cases and simple business language. There might be sections that get a little heavy, but I promise if you stick with me, you and your business will be better for it. Please feel free to drop questions in the chat as we go, uh, just to make sure you're not preoccupied with trying to remember any thoughts. But then we can dive into them once we get to the Q&A at the end. All disclaimers up front. If you have a different opinion, if you disagree with me, please find me either in public in my daily life or on a public social media platform and harass me and correct me in the open. It's the only way I take criticism. All jokes aside, please do reach out if you have any questions. I'm very responsive and I'm happy to participate in thought share. I'm also excited to discuss a critical issue facing modern businesses. It could be deemed the paradox of data abundance. In an era where data is often touted as rocket fuel for a business, a lot of organizations find themselves drowning in data, but starving for actionable insights. In other words, failing to, activate, you could say, their data. There are a few main reasons for this activation gap. The first would probably be siloing data, meaning companies have data spread across departments and systems, making it difficult to get a unified view of the business. Sales, marketing, finance, operations might all have valuable information, but if these data sets don't communicate with each other, you're going to go into the market or go against your competitors with one arm tied behind your back. Another reason is data governance and quality, insofar that data quality issues and lack of robust data governance frameworks can lead to unreliable insights, inaccurate or outdated, incomplete data can even undermine decision-making processes at the C-level and erode trust when you promote data-driven insights. There also are reasons for this activation gap when you look at architectural limitations. Many organizations have invested in a plethora of data tools and platforms. A lot of them overlap and have redundancies within their systems. And getting all of these working together and integrated in order to work seamlessly is often a complex and resource-intensive task. This presentation really focuses on establishing a unified data strategy, or in other words, how you can develop a comprehensive strategy that aligns with your business goals by breaking down silos and creating a centralized, democratized data repository where data from all departments can be integrated and analyzed collectively. This will be discussed in 3 sections. The first is aimed at diving into how data can be used. Next, we'll be taking a look at a few buzzwords in hopes of adding color so we can leverage them in the last section, where we'll discuss what it means to productize your data, really where we start to derive and drive value with it. I will likely be spending more time in the first 2 sections as they are foundational to any action items that come out of this presentation and are less variable than something like solution architecture and the specific way that a domain or an organization productizes their data. So enough small talk, let's dive in. Generally, we nerds agree that there are 5 types of data analysis. Each provides a specific type of value and requires certain types of methods to turn raw data into actual intelligence. If data is rocket fuel for the business, we're about to go through and we're about to learn about different refinery methods. The first is going to be descriptive analytics. Descriptive analytics answers the question of what happened by summarizing historical data in order to provide kind of a clear view of past events. It's often communicated to stakeholders via tried and true methods and channels like reports, data dashboards, and best practice visualizations. To simplify this even further, let's do a non-business example, and let's take a car, right, or a vehicle with an odometer. the odometer being the thing that tracks your mileage. The odometer can't tell you what's going on with the engine, where you've been, or where you're going, but it still provides value. Many use the odometer reading as the basis for things like warranties and servicing. So in this example, our mileage on the odometer is serving as a proxy variable for other more complicated concepts. Next, we have diagnostic analytics. This is where we start to be able to derive insights. It delves deeper and complements descriptive by asking, why did it happen? This type of analysis identifies root causes, correlations, and relationships so teams can understand the underlying reasons behind observed outcomes. Keeping with our car example, think of this as your dashboard or the warning or the light system on there, right? Whether you're using the gauges to troubleshoot an issue or plugging in a code reader to your vehicle, you're really trying to investigate the reason why or the reasons behind a given notification on your dash, a given warning light. You can do some drill down analysis, data mining, a lot of correlation analytics, something as simple as the Pearson correlation coefficient and line of best fit all the way up to like non-linear regression. You can get as interesting and as fun as you want. But moving forward, we're moving out of one area, and with predictive analytics, we're moving from what was known as informational analytics into a new domain. Because predictive analytics focuses on forecasting future outcomes by answering the question, what is likely to happen? Here, teams leveraging things like statistical modeling, machine learning, and time series analyses map out likely futures. I guess to stretch an already tired analogy even further, imagine if a car could predict when you would need to get gas based on your weekly driving schedule, and then provide a message on your screen that says, be ready to fill up this Thursday, right? That would be predictive, right? It would be saying, okay, based on what I know, based on these patterns, based on the computations I'm doing, I'm projecting this potential future and updating it as I'm fed more information. A quick sidebar here, and I won't go full stats nerd, but we are in a very interesting time in data where we have full or complete data sets, something that has historically been uncommon, or I guess more uncommon. Anyway, if you want to go down a rabbit hole about what statistics looks like when you have all possible observations, for example, all of the sales you made within a given year, do some reading on metaphorical populations and alternative histories. Really interesting stuff. But anyway, moving forward, we want to move from predictive to another complementary one called prescriptive. In the same way that diagnostic help build on top of descriptive, prescriptive builds on top of predictive. It takes the things that we did before and moves it further up the value chain and adds an additional layer by not only predicting future outcomes, but by also recommending actions to achieve desired results, right? This is aimed at answering the question, what should we do? This is more consultative. You're getting way more value when you can answer this in your given business context. So in our last example, our vehicle could anticipate when we need to fill up based on historical driving patterns. So let's take that a step further and imagine if, in addition to constantly projecting when you need to fill up, it could use live streaming gas price data and your historical driving patterns to tell you where you could fill up for the cheapest, and it would advise you like that. And then finally, we move to where all of the hype is these days, cognitive analytics. This uses advanced technologies like artificial intelligence and natural language processing, the holy grail of large language models and conversational intelligence to mimic human thought and processes and to answer the question, what can we learn? The objective is to enable systems to learn from data, adapt, and provide deeper insights at large. I guess to close out our automotive motif, I present to you the final example, Knight Rider. All jokes aside, think of our previous examples and consider what it would look like to have a vehicle that is linked to something like your calendar. Using all of your data to make projections about your driving, to plan refueling stops, auto schedule maintenance appointments for you, auto recommend the shortest route to accomplish all of these things. That is where we are headed, and where we're topping out on the value scale in terms of these types of data analyses. you know, with increased value, you do get increased difficulty. I'm not necessarily espousing that it is, this perfect linear progression, very gradually increasing. I think that's up for debate. But for the sake of visual, we do see a trade-off of value and difficulty. We see an increase in both value and difficulty as we move through these different stages. But for a little bit more nuance here, we've covered some of this already, but I want to quickly call out an important back-end difference for these types of analytical approaches. It is the difference of, I guess, deductive and inductive research. Each is a tool, but specific problems call for specific tools. The next few slides are meant to give you a high-level account for the difference, top-down being deductive, bottom-up being inductive. Let's see what this means practically. Starting with top-down, we take a pre-existing theory or concept and see if we can validate it or refute it. To drain this slide in order to help elaborate on this, let's take the example we have up top. We believe that reducing the number of touches a customer has to have with our post-sales customer support team will increase customer loyalty. Here, the business has a theory. So they would utilize descriptive and diagnostic analytics to aggregate the appropriate data or observations and to run a bunch of tests to validate, confirm, essentially see if there is a correlation between those two things. What kind of correlation, what is its magnitude, so on. But the key difference is that you're starting with a pre-established theory. We believe that, and that is in contrast to inductive analytics. This is the other side of the coin, i.e. bottom up. Here, the business is fully in discovery mode. To drain the slide a little bit again, it's through the analysis of data. So let's go through this example and then I'll add some more color. Through the analysis of customer behavior, we've identified an emerging trend. Customers who buy online and pick up in store reach out for support more frequently than those who make in-store purchases. Observing this relationship and pattern, going in, developing a hypothesis, testing it out, this can lead to new theories that we can then operationalize and move to the far left side of our scatter plot. But we get a lot more freedom whenever we get to work in inductive because, again, this is explorative. You're testing, you're validating, this is inductive. Math underpins all of this, but these are some of the bits of minutia that will help you know what tool to reach for, because understanding these methods enables businesses to be able to comprehensively address past performance, uncover underlying causes, anticipate future trends, recommend strategic actions, and then eventually leverage AI for advanced insights. So with that, let's drill down and get into some buzzwords. Here, we will try to explore 3 buzzwords. I know these slides are heavy, but I will be providing one-liners for each of them. We're going to kick it off by looking at a data lakehouse. A data lakehouse is a technology, right? It's a technology that combines aspects of a data warehouse with a more modern data lake. Data warehouse, data lake, all of these other synonymous technologies, right, are commonly associated and used for what we would call a master data layer within an organization, this kind of central repository. But in the words of Databricks, I love Databricks, by the way. Look into Delta Lake and how it changed the game. But in the words of Databricks, a data lakehouse is a new open data management architecture that combines flexibility, cost efficiency, and the scale of data lakes with the data management, of historic systems like data warehouses. To paraphrase, to not fully drain the slide. There's a graphic here that is directly from their site showing the structural and process-centric differences between each of these 3 master data tools or solutions. Now, let's jump over to Fabric. A data fabric is an architectural approach, not to be confused with a given solution with a given, I guess, like software that you can purchase. The closest person to being able to offer that in market is I would suspect Microsoft, with the release of, you guessed it, Microsoft Fabric last year. It was overshadowed by GPT, but very useful for civilian developers, for in the department, in domain business intelligence teams. Very low code, no code, easy to scale. We can talk about that more later if we want, but it's an architectural approach right now. And that's kind of how Gartner describes it as well. I include their definition here, but it's enabled by various data management solutions, and it's centralizing data access across all endpoints, whether that is from an on-prem solution or in like single cloud or multiple cloud environments. The end result should be a layer or a fabric of data connecting processes. It utilizes continuing analytics over existing discoverable and inferenced metadata assets to support the design, development, and utilization of integrated and reusable data across all environments, including hybrid multi-cloud platforms. Right? I think I'm really trying to emphasize the flexibility. But beyond that, I think there are a few concepts worth noting, because we're going to be leveraging all of these moving forward, but we need a more detailed account of fabric and mesh to get as much as we can out of later slides. So the first concept worth noting is that fabric aims for unified data access. It does this by integrating data sources to accomplish a centralized, or I guess a more fun way to say it is to accomplish a centralization of information. The centralization involves integrating data from multiple, often disparate sources, such as databases, the data lakes we're talking about, data lake houses, cloud storage, on-prem. And this integration provides a single point of access for all data consumers. This centralization then provides a consistent data view where users can access a comprehensive and stable view of the data, regardless of its original form or location. That view facilitates better decision-making and analytics, regardless of business context. The second concept is key, and we'll wrestle with it more in a later slide, but establishing standardized policies for data governance and quality. This is done to ensure data quality, security, and compliance across the org. In turn, your organization gets enhanced data quality, as we mentioned, by applying uniform data cleaning, validation, and enrichment processes. By doing all that, the overall quality and reliability it's raised exponentially when you have those things in place. That in turn enables the next concept, which is scalability and flexibility. A data fabric provides a scalable architecture that can grow with the organization's data needs. Centralizing data helps in effectively managing and scaling resources across the globe. It also allows for the integration of new data sources and technologies as they emerge or come onto the market. And that's what's providing that flexibility to adapt to changing ecosystems and business requirements. Fabric also focuses on enhanced data security with centralized control. That's a big tenet of Fabric. Centralized control makes it easier to enforce security policies and monitor data usage. An example of this is the ability to have consistent security measures, ensuring that those measures are applied across all data sources, reducing the risk of data breaches or unauthorized data access. And then finally, improved insights, right? You get comprehensive analytics. You can build out real-time analytics out of the centralized data fabric, pushing it through even for event-driven data, calls, purchases, things along those lines to better fuel timely insights and decision-making. So, take a breath, get a drink of water, and let's jump over to mesh. A data mesh is currently defined as a set of 4 principles or concepts that allow a central set of governing standards to underpin a distributed data architecture, shifting the focus onto business domains and productization of their data. When I say business domains, think of teams, think of departments, think of initiatives, domains being kind of a section or a group defined by objective within the business. Its aim is to increase value from data at scale, sustain agility as an organization grows, and embrace change in complex and volatile business environments or contexts. Where data fabric is technology focused, the data mesh is all about people and process. O'Reilly Education summarizes it as a data mesh is a decentralized socio-technical approach to share, access, and manage analytical data at a complex and large scale. It does this via 4 core principles. You can see here on the right. The first is domain ownership, where those business domains that we discuss fully own the data that they retrieve, produce, add computations and intelligence upon. They fully own it. They're in charge of it, and they serve it as a product, goes in the next portion, data as a product, to other departments, back into the main system, or even external customers who want to purchase their data. The idea is to enable a self-serve data platform where you're walking up and you are able to retrieve exactly what you need and know that it meets all of the standards and expectations of what you have. Final is a federated computational governance system and process. And we'll get more into that later. It's a mouthful and a headful. But let's really zoom in on data as a product. That is a key shift in paradigm or mindset that will help you move from data just being there, data just, gathering dust, to actually driving innovation and creating value within your org. Doing this allows you to derive and drive value with your data from internal stakeholders, as we talked about, the different business domains, the other departments, the other teams, and users from those domains, or even the market at large, where you are able to monetize certain aspects of your data, whether for research purposes, selling it to a larger agency, sanitized versions of customer demographic information, however you're doing it. The idea is make it start driving value internally and externally. TWI has defined it as a process by which businesses transform their information into better decisions, more efficient processes, and other positive outcomes. So how do we do it, right? Most data ecosystems build data products that are aligned to data strategy. So in the majority of those scenarios, a combination of both operational data and analytical data are needed. It's in order to achieve that, you're going to need both. Thus, I would encourage you to reject the binary and build upon your existing master data layer with a blended or hybrid architectural approach. By blending the centralization of data fabric with the decentralized data of data mesh, we can create a robust hybrid data management approach that leverages the strength of both frameworks. This hybrid approach aims to achieve unified governance and accessibility while maintaining flexibility and domain-oriented data ownership. There are a few key ways to do this. One, establish a unified data governance framework to enable centralized governance with decentralized execution. Via the strategic use of policies and standards, organizations can develop centralized data governance policies and standards and best practices that should cover data quality, security, privacy, and compliance requirements. Then you need to have domain-level implementation of those standards. In other words, allow individual domains within the data mesh to implement these policies autonomously. This enables local control and accountability while ensuring adherence to overarching governance standards. Two is going to be the way you leverage a metadata management and cataloging system via a centralized metadata repository. In line with Fabric, one should implement a metadata management system within the data fabric that acts as a kind of single source of truth across the organization. But you must be sure to allow for domain-specific metadata integrations. Enabling these domains within the data mesh to contribute to the centralized single source of truth for metadata can create a unified catalog that provides visibility into all data assets, their lineage, and their usage across the enterprise. Next, we've hinted at it so far, but enabling data interoperability and accessibility through solutions like data virtualization and API integrations. With this, we can use Data Fabric as an interoperability layer to provide virtualization that abstracts the underlying complexities of the data and allows you to access it. Then the development and the standardization and the publishing of APIs would allow for domains, as business departments, as business teams, to interact with data from other domains through these APIs without having to go through IT, without having to go through a specialized intelligence team and analytics team. It gives them far more autonomy, ensuring that it's the same data across the board and it can operate with their existing data sets. This is a lot like traditional data marts. And these next few are key. We need to embrace a federated data architecture. A federated data architecture is a distributed approach to data management that allows for a decentralized data storage and governance and processing kind of architecture, while providing a unified interface for the data to be accessed and analyzed by the whole organization. This architecture enables you to have the data remain in its original location, oftentimes managed by various departments or business units, while it can still be accessed and queried in a cohesive manner as if it were centralized. You should also develop unified security policies, but ensure that we allow for local enforcement. The centralized security framework should outline data access controls, encryption standards, and privacy measures, while local security enforcement enables domains to enforce them within their own data environments, ensuring compliance with these central policies while still allowing for domain-specific customizations. Finally, foster a collaborative culture. Really aim to increase data literacy and cross-domain collaboration via training. This could look like a number of things. An example is establish a data stewardship program that promotes collaboration between the centralized data governance team and these non-specific area kind of domain data owners. And it could look like investing in data literacy programs and trainings. It could manifest in a lot of different ways. But let's look at what all of these could look like or how they could present themselves practically. This slide stands on the foundational work of thought leaders like Jim Dong Sun and Nathan Mars. Nathan Mars, who originally coined kind of this architectural idea as batch/real-time architecture. The diagram to the right we're looking at here shows how one can blend concepts from both mesh, what you're seeing in the kind of salmon color, the lighter blush, and the arrows going down to the end users, and fabric designs. Fabric designs being the kind of electric blue, teal lines and dotted line outlining data platform, and how you can integrate those to build a more intelligent system around an existing master data storage system. This is a visual that I made with inspiration from existing best practice layouts and examples. It is a Lambda architecture because you have directional definition. And it's one of several architectural designs for a hybrid solution. This one specifically easily folds into most existing layered tech stacks, skillfully handling, the collection, management, and analysis of data agnostic of source or destination. Even though there are many design patterns that focus on certain areas of data management uh, and data types, in the real world, you, I guess, as more and more data is generated with different formats, you would need to, and various businesses would need to consider hybrid models if they're wanting to be future proof. Each business will have different needs and different requirements, different legacy systems and objectives. So this is the portion that's highly variable, as it won't be a one size fits all, but this is kind of the will likely apply to most people approach. Um, Also, you can iterate on it. Take a screenshot, make it your own. Go ahead. All thought share. But I want to double click and zoom in on the connective tissue between methods. This is where we'll harken back to embracing a federated data architecture within this hybrid approach. This is how you could use both domain driven ownership, i.e., like decentralized data principles from mesh, and layer in fabric tools and rules to build centralized data stores, which are fed by, these domains and their data sets. We're seeing up top, we have our like in-house infrastructure. Then within the data platform, we have our master data storage at the center of it. So regardless of what you're using, you can still layer in fabric techniques. Fabric is an architectural, right, approach. So you can throw that into your existing tech stack and then run it via EVTL or ETL, extract, verify, transform, load into these specific domains down here. And then those domains can run it from their own native data storage system all the way down to product delivery to end users. And end users could look, again, like internal or external stakeholders. And those end users could also be taking information from multiple domains, multiple business domains to curate the information they need so they don't have to recreate the wheel. I know I've only depicted two here, but the idea is you can add as many domains as you want within this collaboration solution, right? Within whatever data management collaboration solution or solutions that your company is leveraging. And that's really the heart of it, is you don't have to lift and shift. You don't have to destroy all of what you currently have. You can incrementally implement these concepts, these architectural approaches to, as a smart guy once said, experience innovation without disruption. And Avaya is actually in the process of doing this, and this will be reflected in a lot of the products and product features that external users get to see, as well as internal stakeholders and business departments. So with that, we have come to the question and answer portion. We try to leave roughly 20 to 15 minutes for that, but if we don't take up the full time, don't worry about it. Before we get in, I do want to plug our upcoming Lunch and Learns. We have the Future of Analytics on June 5th with Mike Tinnery. And then we have Curtis bringing us how to do the things you used to do before an AXP on June 12th. And I would encourage you to look at those as they complement this. And if you are a customer, will help you apply this and get you up to speed on where we're headed. But outside of that, I would love to open the floor to questions.
I guess I'm in my head, I'm kind of trying to visualize at the virtual infrastructure behind some of these models. Obviously, you've got a million different applications with their own native data sources. Some are structured data, some are unstructured data, each with their own ways of interacting. Are you? Is it like a number of middleware layers in the middle So, I mean, you showed a number of layers between the users and the data, and the different models showed different ways of them interacting. But like architecturally, if you're trying to build this, and I'll say like your Lambda model, right, which was kind of a
Mhm.
hybrid of the two, what kind of tools are you putting in the middle? Is
Yeah,
it,
let's jump back here.
yeah,
So, and this can vary, right? The tools you use could vary by, business business requirements and business needs.
hmm,
But the end users here aren't necessarily. Uh, it doesn't take this long to get to value. I think that's the point. What you're doing is
yeah,
you are saying we have this underlying infrastructure within IT. We already have a master data storage system, whether it is a data
okay,
warehouse, whether it is, right? So we have this centralized repository of data. And now at
well,
this level,
let me pause
oh,
you
good.
right there. Sorry.
Yeah, that's okay.
So, because that seems to conflict with use the data where it is approach, not try and put it all in one spot. Or did I just misinterpret that earlier?
So that's where I would double down on the virtualization layer, right? And the access
Okay,
of centralized data at the domain level without having the duplication of data. So mesh
right.
being we are accessing and querying this data without duplicative storage with that, right? So I guess to continue answering the question and lean
Hmm.
towards where you took it, you have this master data storage system and you're ingesting real-time data into it. You have your static data sources. And then if we jump over to collaboration, right, solutions, let's use
Right,
what Avaya currently has. So Avaya currently has, it's a Microsoft suite from Azure to uh, Microsoft, Fabric, SharePoint, Power BI.
right,
Using that as an example, this is our collaboration solution. We can then ingest from existing data warehouse cubes, a data lake, a whatever we're doing from data bricks, from a blob storage system. We can
right,
ingest via virtualization into something like a one lake, within Fabric, or a specific via a data pipeline in Microsoft Fabric. We can start loading those into semantic models or relational tables without having to duplicate and take up kind of more storage and set auto refresh rates. So it's the idea of you're centralizing it, but then rather than seeing this, and I should have mentioned this earlier, because these can seem conflicting, where you're saying
hmm,
centralize it, but also decentralize it. I think there is good reason to switch from the phrase of decentralization to democratization. You are centralizing resources, but then democratizing with standards, with structure, the accessibility of those resources and depending on the solutions you choose, there's no shortage of data management solutions or tools or platforms, Cloudera, uh, all the way to Clipfolio, um, and in between, right? There's unlimited, all varying in technical prowess. But it's the idea of centralize it and then democratize it um, as best you can, where these operational domains are in charge of the net new data that they generate, enriching it with anything from the master data that they need, running it through computations, intelligence models, knowledge graphs, etc., finally producing a data product and then pushing that data product to end users. That could be leaders within this department. That could be um, external research firms who are, taking this data and running with it and using it as a cited source in their own publications, etc. But the idea is centralize and standardize the collection and storage as light of a framework as you can, to where you can entertain things like, let's use a data lakehouse where it can be structured or unstructured. It doesn't have to be schema'd before it goes in, right? Like it can be schema on call, where you schema it as it comes into the collaboration solution, where you're defining the data type of the field as you need it. And you can have the same field registered as a different data type in different business domains. But it's still, as long as that's permittable within your governance and accessibility and everything. But like, that's the idea, is we don't want to duplicate the storage. And we want it to be as flexible as it can be when we pull it in this portion of the fabric. And this represents the connective tissue, what I was saying, where we say, okay, fabric centralization democratized through a collaboration solution where we are applying schema here, we are selecting, the dimensions
You're doing
of data that we
ETL
want.
to make it. You're basically doing ETL to make it like human consumable, for lack of
Exactly.
to ultra simplify.
Yeah, exactly. That way
Yeah.
it meets the specific needs of the data product. That way you're never like getting too much. You're getting exactly what you need in the format you need it. So you can try to automate its downward progression as much as you can, to where it's in its usable form and going through product delivery as quickly or as like seamlessly as you can. Does that help answer your question?
That was helpful. I might
Cool, yeah.
actually ask for some recommended reading, if you don't mind.
I have so much. Oh, of course. Yeah. This is very, very interesting to me. And I think getting into interoperability, data virtualization, and domain access, API building, query engines, all of these different things can be a session in and of itself. But I hope this is giving you I wanted to make this compelling and interesting, so I hope it's spurred on some good questions and considerations.